we're going to do is we're going to get into some of the more advanced concepts that should be a little bit more familiar from Algebra 2. Yeah, I know.
Is it going to be more difficult?
Yes. That's why it's called the Passport 2 Advanced Math.
That's not good though.
So,
wait, we're back in Algebra 2.
So it gets worse.
we're going to start with operations with polynomials, add, subtract, multiply. I'm also going to add in divide. There's a couple times where those actually end up being better. And then building some functions and equations to represent different contexts. Okay? So, the trick is with a lot of these questions, they are written in such a way that there's a long way or a short way. You should be able to solve these in under the average of 2 minutes. Okay, that's generally how much time you get for these types of questions. But that faster method may not always be as apparent. So we're given two polynomials that are set equal to each other, and we have this constant b. If the equation is true for all values of x, what is the value of b? Recall that if it's true for all values of x, that means our solution is all real numbers. So what do we have to have with our equation on both sides for our solution set to be all real numbers? We saw this in heart of algebra.
The same slope.
Close.
Different slope. Same.
Nothing. I mean, you're kind of on the right track. Think about it this way. If I want my solution to be true for all values of x, then it should mean it doesn't matter what I plug in for x, I'm always going to get the same thing. So what does my equation on both sides have to look like?
The same.
The same. They have to be the same. So what is our instinct to try and do to figure out how to get them to be the same? Distribute. Multiply what we have on the left and see what we can do to make it look like what we have on the right. Which is fine, but that's the long way. There is so you can distribute, you can multiply, and then try and group like terms and figure out what b needs to be. But there's a faster way, which is kind of understanding what polynomial factors are. So let's take a step back and think in some general terms. Let's make this first polynomial a, the second one b, and the last one c. If I take a times b and say that it needs to equal c, in order for me to get all real numbers as my solution, a times b has to equal c. The problem is I don't fully know what a is. I know what b is, x plus 3. I know what c is, it's that cubic polynomial. But I don't have what a is, so I can't really multiply a and b to figure out if it equals c. But if we work backwards and think, well, if a times b has to equal c, well then c divided by b has to equal a. C divided by b has to equal a. We should be able to work backwards and get the same result. That's like isolating a. Divide both sides by b. So c divided by b has to equal a, which means that x cubed plus 6x squared plus 7x minus 6 divided by x plus 3 will have to equal that polynomial. And once we know what that polynomial has to be, then we can just use visual inspection to solve for b. The reason that this works better is specifically because of that binomial, x plus 3. If it was anything else more complicated, then division's not going to be the fastest way. But division's going to be the faster way here because we can use synthetic division. We can use synthetic division because we have a linear binomial whose coefficient is 1. There's no exponent, There's no coefficient. It's x plus or minus a number. And as long as we can do synthetic division, it's going to be our faster shortcut. Well, good thing we're going over it right now. So, set up our synthetic division. Inside the box, we're going to be using what would be the solution to that binomial. If I set x plus 3 equal to 0, what does x equal? Negative 3. That's the number that goes in here. Since x equals negative 3, that's the number that goes up there. Next to it, we're going to take our polynomial and we're going to strip out all the exponents and all the variables. And we're going to keep just the coefficients and the constant. 1, 6, 7, negative 6. Once we have that, now we can go through the process of synthetic division. Bring down the first number, and then we're going to multiply. Negative 3 times 1 gives me negative 3. Put that underneath the next column, and then we're just going to repeat that process of add, multiply, until we get all the way to the end. 6 plus negative 3 is 3. Multiply, add, multiply, add.
Wait,
Yes, we need that last number to equal 0, because if it doesn't equal 0, we have a remainder, and then if we have a remainder, what that means is that x plus 3 isn't a factor of that polynomial, and then all of this was for naught. We need that remainder to be 0 because we're banking on the fact that x plus 3 can be divided into that polynomial. That x plus 3 is a factor. We need it to be a factor for this to work. So this last number is our remainder. The rest of it is our quotient, starting with the constant and then just working up in our powers. So this second number is our constant. The next number is going to be our x, and then x to the second, and we would keep going until we ran out of numbers. So I have x squared plus 3x minus 2 as the quotient with a remainder of 0. Well, let's compare that to what we have up top. X squared plus bx minus 2. What does b have to be? 3. So it's recognizing these patterns. And these relationships between factors and quotients and products and so on. Yeah.
So for that part of here, you just
Yep. So everything in this row gets multiplied by negative 3. We bring down the 1, and then we multiply, bring it up a row, and then add, and then we multiply again, bring it up, add, multiply, bring it up, add. Yeah.
Can you explain how we got B with 3?
Now, which of the following is equivalent to 16 s to the 4th minus 4t squared? What process would take this binomial and give me a bunch more stuff?
Division.
Sort of. It's part of it. What takes a polynomial and splits it up? Factoring, which is division. Okay? So we're factoring it. We're taking something and we're splitting it apart through factoring. But this is a special type of polynomial which has a special type of factoring.
Square polynomial.
Square is a special type of square. Square is a special type of perfect square.
Cube perfect square.
What operation do I have in the middle there?
Subtraction.
What's our math term that means subtraction? Starts with a D.
Distribute.
D. Difference.
Oh.
We have a difference of squares. A difference of squares always factors to a sum and difference of the roots. So we have a special case polynomial. Okay? Perfect difference of perfect squares. Now we also have a greatest common factor. 4. Always factor that out first. It's going to make your life significantly easier if you see a greatest common factor. If I factor out 4 from 16s to the 4th, what do I have left? 4s to the 4th. And then out of 4t squared? T squared. And then we can use our difference of squares to factor what's left. Make sure we bring down the 4. All right? So we want to square root the first term. What is the square root of 4s to the 4th? T squared. So, what's our answer? C. So, knowing your special cases. Alright? More factoring. So we've got a polynomial, y to the 5th minus 2y to the 4th. Yeah. In the polynomial above, c is a constant. So again, something that we don't know. We've got to figure out what it is. If the polynomial is divisible by y minus 2, then what is the value of c? If a polynomial is divisible, it means that that is a factor. That's that knowledge that we used in that very first problem, was that, okay, if this is a factor, then it's divisible. We can do division with our factors. So y minus 2 is a factor. I need to figure out how to factor this and end up with y minus 2, and what value of c would make that happen. So a couple things we need to notice. One, I have 4 terms, so I can't use any of my trinomial factoring methods. It's not a difference of squares or any other special case. But if we've got multiple variables and more than 3 terms, our only option is factored by grouping. So we need to take our first and last term, or sorry, first and our second term, set them as one group, and the last 2 terms, and set them as another group, and we need to factor by grouping, which means we're pulling out GCFs within each group, but we should end up with the same thing on both sets. So what can I factor out of my first 2 terms that will leave me with y minus 2? Y to the, not the 5th, the 4th. That'll leave me with y minus 2. Now I need to do the same thing with the second group. I need to figure out what could I factor out that'll leave me with y minus 2. Okay, I need to factor out x. What else? I need to factor out a 3, right? But not just a regular 3, because that would just give me a positive 2. A negative 3. I need to factor out a negative 3. Okay? So now we're going to look and say, all right, well, if I factor out negative 3x, that turns this term here. So then we just need to focus on this part, because this leaves me with the y here and here. Again, through some visual inspection, what does c?
3.
Not negative 3, it's already negative.
Positive 3.
Positive 3. I've got the negative, I've got the x. C just needs to be 3. Okay, so there's all our factoring. All right, a bunch of different ways for factoring. So now, got some more division. Which of the following is equivalent to 6x to the 3rd squared plus 5x? It's a good habit to always kind of look through your answer options and reference those. repeatedly throughout the solving, especially with some of these more complex ones, because you may, one, get a hint as to what it is you need to do, and then two, you can keep checking in to see, hey, can I eliminate some of these options or can I make a final decision? When I look at these answer options, I can see, well, there's one that's starkly different from the rest. B, probably not going to be my answer. And then each of these kind of expand. I've got 2x, I've got 2x minus, I've got 2x plus 1 minus something. And what else I want you to notice is here, these look like remainders for quotients when we're dividing polynomials. If we have a remainder, we always write it as plus or minus something over whatever it is we're dividing by. That's a common pattern that shows up when we do polynomial long division. And so that gives us a hint that we should be doing polynomial long division. Luckily, this one's going to be pretty simple. We're missing our constant term, so let's just put in a placeholder 0. We may not need it. It's better to have it and not need it, need it and not have it. So our polynomial long division. First term of the dividend and the first term of the divisor. Divide them. What do we get? 2x. Then to figure out what we have to subtract, we need to multiply that 2x by the divisor. The entire thing. 6x squared plus 2x. And then we subtract. 6x squared minus 6x squared. That cancels. 5x minus 2x is 3x. We're subtracting. Bring down your placeholder in case we need it. And then we repeat the process. Change colors here. I'll take 3x and divide it by 3x. What do I get?
1.
I don't need to keep going. I can already see my answer. It's the only one that's 2x plus 1. If we want to check, we can get our remainder.
Why is it just
Well, 3x divided by 3x is 1.
Oh.
So I put plus 1. Now I'm going to multiply. And that cancels. That equals negative 1. That's my remainder over the divisor. But once I reach 2x plus 1, that's the only one that's got 2x plus 1. So I can just mark it and keep moving. If you got time, you can come back and check it. But anywhere you can save yourself an extra 15 seconds adds up. This equation looks more complicated than it actually is. The large exponents are there to give you a little panic attack. You're not actually really going to do anything with the exponents.
Oh. Can you just multiply the second bracket by 2?
Sort of. You're on the right track. But we're going to fine tune that a little bit. I've got fractions. I need to multiply so I have a common denominator. Otherwise I can't do anything with the fraction. So I can definitely multiply these, that by 2 over 2, to get that common denominator. Changes that to 2 over 88. Okay? But what else do I have to do before I start combining like terms?
1 and negative 1/2.
They do. That's a pretty easy addition to do, but yeah, we can rewrite that as 2 over 2. What else? What do I have right in the middle?
Oh, it's a negative, so you have to make it.
Yeah. That's what's going to throw you off. That's going to be the difference between the right answer and the wrong answer. It's whether you remember to distribute that negative and whether you remember to distribute it properly. Because everything in the second binomial is going to change its sign. So I have 1 over 88y to the 100th plus 2 over 2 minus 2 over 88y to the 100th plus 1/2. So the difference between remembering that distributive property is the difference between 1/2 and 3/2, which we have as options on all of those, 1/2 and 3/2. So if I combine 2/2 and 1/2, that's 3/2. So I can get rid of option A and option C. That combines to 3/2. And then the y to the 100th, again, that's just there to freak you out. You're not doing anything with it. It's like terms. You're combining like terms. It's the same as if you had y squared. You're adding your coefficients. So if we've got 1/88 minus 2/88, -1 over 88. That just follows. B is our option. Which of the following expressions is equivalent to 7k minus the product of k plus 1 and 2k plus 2? So we've got an algebraic sentence. We need to write it into an algebraic expression. So we'll just run through it from left to right. 7k minus the product. What does the product mean?
Result.
We're going to multiply k plus 1 and 2k plus 2. Now, what's really important here is, remember, we're subtracting. So when we expand this out, we're going to end up with a bunch of terms. We need to remember that that subtraction applies to every single one of those terms, and we have to do the distributive property just like we did.
To both. You're doing it to both.
We'll do it. We'll have 3 terms. Once we multiply, we need to do all of it. So we'll do distributive here, expand that out. So k times 2k is 2k squared. K times 2 is 2k. 1 times 2k is 2k. And 1 times 2 is 2. But that entire thing is being subtracted. So we need to throw it back in parentheses so that we end up with the correct signs. Okay? That's what's going to throw you off again, is paying attention to that structure. So we can combine the like terms and then distribute that negative. Now, before I even combine like terms again, I already have enough information to pick my answer. Now, look carefully. Look what we have so far. Compare it to our answers.
So it's not C or D.
It's not C or D. Why do you think it's not C or D, though? I'm curious.
Because of the negative.
Hey, good. Yeah. We have this constant. All right. It's not going to be that.
Oh, it's A.
Why?
Because of the.
Yeah. There's no like terms to combine with the k squared or with the constant. The only one that has those that matches is A. If we continued and combined the like terms, well, yeah, we'd end up with 3k. But we don't need to. We already had enough information to pick what we had. Save yourself some seconds. So always kind of be checking in with those answers and see if you've got enough information to make a decision on what your final answer could be. And then come back later if you have more time, finish working it out. Make sure it tracks. Save yourself those precious, precious seconds. All right. These solutions look like a special formula. Yeah. When we use our quadratic formula and we get a solution that's an irrational number, they always look something like that to some degree. A number, plus and minus, the square root of something, over something else. So our quadratic formula, negative b plus and minus square root of b squared minus 4ac all over 2a. There's our quadratic formula. Does anyone else sing the song in their head when they're writing it out?
Yeah.
I do. Stuck there forever. Lives rent free in my head. So, in order to use the quadratic formula, our equation has to be in the form of ax squared plus bx plus c equals 0. So what am I going to do to my equation so that it looks like that?
Plug in.
I got to change this,
You gotta move
move the x back to the other side. What I want you to look at real quick, just a quick skim. These answers don't look that different. I've got either a -1 or a +1. I've got a √11 or a √13. The location of this x is going to change the value of b. The value of b, being positive or negative, is going to change to those different options. So if you forget to do that, you're going to think you did it right because it's there. Excuse me. So if I have x squared minus x minus 3 equals 0, subtract that x, comes to the other side. What's the value of a? What's the coefficient on x squared? 1. What's the value of b? -1. That's going to make a big difference. What's the value of c? -3. So then I can plug those all in. So negative b plus or minus the square root of b squared minus 4 times a times c over 2a. The only things I need to pay attention to are the only things that are different in each of the answers. Negative b and what's under the radical, also known as your discriminant. Those are the only things you need to pay attention to because those are the only things that change from answer to answer. All right, looking at -1, that eliminates what options? It eliminates a and b because that gives me a +1. It would be helpful if I change that to a pen. Okay, so we can eliminate those two. All right, so then we're looking at our discriminant. Is -1 squared minus 4 times 1 times -3, is it equal to 11 or 13? One plus 12 equals 13. So that leaves us with answer option D. All right, solving quadratics, solutions to the equation. Notice how we only have one term with an x in it. That's our case. Our square root property is going to be our best friend. Square root property only works when we have one term with the variable in it. But what it does is it allows me to isolate my squared term and then square root it. So how do I get rid of that 4? What is 52 divided by 4? 13. Yep. Now I can square root both sides. X was isolated. Square root. So x equals, can I square root 13? No. Can I simplify it at all? No, but I need to remember whenever I square root, how many answers do I get? Plus or minus. So whenever we're using that square root property, we get the positive and the negative root. We get both. What are all the solutions to the equation? X plus 3 times x minus 5 equals 5. A lot of times people are tempted to try and use a zero product property there because oh, it's factored, it equals something. Let me set it equal to what it equals. You can't really do it, okay? We have what's called the zero product property. Well, that only works if our product equals 0. Does our product equal 0? No. So we can't use our zero product property. Unfortunately, we're going to have to do the long way of expanding it all out. Okay? We're going to have to multiply. There, and there, and there, and there. X squared minus 5x plus 3x minus 15 equals 5. Combine like terms, get everything to one side. X squared minus 2x minus 20 equals 0. Alright, so from here our options are several. We can either A, try and factor it to solve. B, we can complete the square so that we can use the square root property. I highly recommend against it because that is the most time consuming of the methods. Or C, we can use our quadratic formula. Which one do you want to guys? Yeah, this one actually can't be factored, so quadratic is going to be our use. We try to see if we want to factor it, what multiplies to give me negative 20 that adds to give me negative 2. There's nothing. My factors are 4 and 5 or 2 and 10, or there's no way to get to negative 2 by adding those. So we'll use our quadratic formula. Negative b plus and minus the square root of b squared minus 4ac over 2a. And then we want to simplify that up. Quadratic formula. Negative b plus or minus square root b squared minus 4 times a times c all over 2a. Now when we clean that up, can I square root 84? What's the square root of 84? 84. Now, but does the square root of 84 have a factor that can be square rooted?
12.
12 can't be square rooted. 6, 4. So I can split that into 4 times 21. What's the square root of 4? 2. So x equals 2 plus or minus 2 root 21 over 2. And then we look to see if we can simplify it even further. What you need to look at is, there's 3 terms in this fraction. All 3 terms have to have a common factor. Yes, they do. But if we look back up here, before we simplified our radical, all 3 terms don't have a common factor yet. I can't simplify because there's no coefficient in front of the 84, the root 84. We need something outside the radical to simplify it with. So now that it's simplified on the outside, I've got 2 plus or minus 2 root 21 over 2. What can I divide all those by? 2. So 2 divided by 2 is what? 1. Make sure that 1 doesn't go away. 1 plus or minus 1 square root of 21 over 1. There's your answer. If x is greater than 0 and we have that quadratic, what is the value of x? So we need to solve the quadratic. They're giving us this here because one of our answers is going to be positive and one of them is going to be either 0 or negative. And so they just want us to have the one solution that is greater than 0 that's positive. So we can factor our trinomial. You can use quadratic formula or you can factor. We've already done plenty of quadratic formula, so let's factor it. So we need to multiply 2 and negative 2. We get negative 4. We need to figure out what gives me a product of negative 4, but a sum of 3. What can I multiply to get negative 4, but add to get 3? Other way around. 4 and negative 1. So we're going to now split our middle term so that we can factor by grouping. Plus 4x minus x minus 2. And then we're going to factor by grouping. We can factor out a 2x and we get x plus 2. Then we can factor out a negative 1 and get x plus 2. These go together in one factor. X plus 2 is my other factor. Now, shortcut to save yourself some time. We are binomials. All right, these are set equal to 0. We need to set them both equal to 0 and solve. But we know that we need to pick the answer that's going to be positive. The answer that's going to be positive will come from the binomial with subtraction. Because in order to solve, I need to add 1 to both sides. 2x equals 1. Then divide by 2. X equals 1/2. If I'm solving for the other one, I have to subtract 2. Well, that's going to be negative now. I don't want the negative answer. I want the positive one. X equals 1/2. I don't want that one because it's going to give me a negative answer. Two minutes. Let's do this. What is the solution? All right. What is the sum of the solutions? All right. So I've got a binomial squared on both sides. I can square root both sides to get rid of that binomial. But problem is, I have to have two answers. That's only going to give me 1. So when we square root both sides, there's this little trick. Okay. I can get rid of the squares, okay? But whenever we square root, remember how we have a positive and negative answer? I have to do that here, but what I need to do is just pick one of them to be negative. So this is going to give me one solution. And then on the right, I'm going to make one of those binomials negative because I'm square rooting. And then from there, we can just solve. 2x minus 1 equals x plus 2. We'll subtract x and add 1. Sorry, I'm going fast. I'll leave this up when I'm done. Here we got to distribute. Minus 2. Add x to both sides. Add 1 to both sides. So we get 3x equals, what am I looking at? Negative 1. So x equals negative 1/3 and x equals 3. I need to add those together. Need to add those together, which is going to be 9 over 3 plus negative 1 over 3 equals 8 over 3. And there's our answer because, again, it wanted the sum of our two solutions.